Okay, guys, so this is the last problem on your worksheet, which is 8. So we're talking about hydrofluoric acid, right? And that combines with silica dioxide, dioxide, and it's going to produce hexafluorosilicic salicylic acid. I can't say that. Say that 5 times fast. Okay. Anyway, it's asking you what the limiting reactant is, and then it's asking you what the percent yield is. All right. So we are going to start this problem the way we start all of our problems. The first thing is we need to figure out which one is the limiting reactant. The only way to do that is to use both of our quantities of limiting reactants and excess reactant to figure out what we make. Okay. What I want to draw your attention to is it says that we have silica dioxide, and it's 40 grams that reacts with 40 grams of hydrofluoric acid, and it reacts to yield 45.8. So this is just another fancy way of saying that this is the actual yield. So we are going to leave that alone until we calculate the percent yield. Okay, so we are going to go from each of the reactants to the product that the question is asking you for. Okay, so let's start off. We have our 40 grams of silica dioxide, put it over 1. Now we're going to work the problem. Gram on the top, gram on the bottom, mole on top. Remember, molar mass is 1 mole, and for silica dioxide, the molar mass is about 60. Okay, we have mole of silica dioxide on the bottom because we had it on the top of the previous equation. And then we need the mole of what we're going to, and that's going to be H2SiF6. Take a look at our balanced equation. Oh, this one's really simple. We're in a 1-to-1 relationship. And then we have the mole on the top, so I need the mole on the bottom. And then I need the molar mass on top. Okay, and that is going to be 1 mole is 144.02. Okay, then we are going to do the math. Whoop. My pen is being bothersome. We are going to get a number of 96.0. Okay, and that's grams of H2SiF6. Okay, now we're going to go from the other reactant, which is HF, which is hydrofluoric acid. We are also starting with 40 grams of that. Put that over 1. Okay, gram on the bottom because we had gram on the top. That is 1 mole is going to be about 20, right? Fluorine is 18.99, and then hydrogen is going to be +1, so 19.99, aka 20. And now I'm going to go mole of HF on the bottom so that my units cancel. And I'm going to go to mole of what we're needing to go to, which is H2F6. Okay, take a look at our relationship. Here we go. We are in a 1-to-6 based on the coefficients. And now I need mole of H2SiF6 on the bottom. And that puts grams of H2SiF6 on the top. 1 mole is going to have a molar mass of the same number up top, 144.02. And then we are going to do the math. And as always, make sure everything cancels so you are where you're supposed to be. And you end up with 48.0 grams of H2SiF4. Okay. This one is the lower number. That means that HF is going to be your limiting reactant. Okay, so I'm going to write that in my first blank. HF is my limiting reactant. Now it's asking me for percent yield. So to figure it out, I need to figure out my theoretical yield. And I am going to do that by looking at what I theoretically make. Okay, so the reason why I went to H2SiF6 is because that's what the question is asking me for. So I know that what I'm going to theoretically make is going to be 48 grams. Okay, so now when we take a look at the equation for percent yield, that is going to equal the actual yield over the theoretical yield times 100. I actually make, right, they tell me up at the top that I actually make 45.8 grams of H2SiF6, but theoretically, when I calculated, it was 48 grams of H2SiF6. Okay, times about 100. The number that you should get should be really close to 95%. And that is the answer to your percent yield. So hopefully that was helpful.